right, so today we're going to start on the next topic, the next module, which is databases in SQL. And in particular, we're going to, we already motivated this, and I showed you how to get set up on your own database on the CSV server. We showed that the flat file representations like CSV files, or in technically speaking, the JSON and XML are still flattened data models. They're not relational models. So they're all, and of course it's also file based. So it's not sufficient for real applications. Remember that we are online, so if you have any questions, go ahead and post to Piazza or to the YouTube live stream. So there are repetition of data, there's consistency issues, there's formatting issues, there's just a whole bunch of issues associated with this that an RDBMS solves. The relational model was created by Edgar Codd at IBM in 1970, so it's over 50 years old now. And the key aspect is that data is stored in tables instead of files. Now, ultimately, at the end of the day, those are still files somewhere sitting on the hard drive or whatever. But they're logically stored in tables and in data structures that lend themselves to very efficient queries and processing. Data itself is stored in columns. Those are called fields. And records are stored as rows. So you can think of a table as kind of like an Excel file where you've got columns and then rows of records. But an Excel itself is not a database, so don't think of it like that. In each table, rows, records are identified uniquely using a primary key, or a PK for short, right? This is usually auto-generated, but we'll talk more about that when we talk about designing databases. Rows in different tables are related to each other. That's where the relational model comes in. They're related to each other through what are called foreign keys. Foreign keys define one of any number of relations. A one-to-many relationship is where you've got table A. One record in table A can be associated with multiple records over here in table B. A many-to-one relationship is just the same thing, but it's in the opposite direction. Table B, you have many records associated with one record over here. An example would be from the video game database. This is a flattened database that we gave you in your first assignment. You had to process it with Java as a CSV file instead of a relational model. But we have those same relations here. We've got a publisher. One publisher can be associated with many games over here, and that's what this ER diagram is depicting. This arrow between these two tables, these two entities, is indicating a one-to-many relation. That's a chicken foot right there, the many, right? We've got games and platforms, and those have a many-to-many relationship. That multiple records in table A can be associated with multiple records in table B. One game can be published on multiple systems, on multiple platforms, and one platform can be, will have multiple games. Otherwise, it'd be kind of you wouldn't buy an Xbox if there was one game on it, right? There's also a one-to-one relationship. That's not depicted here at all because it is kind of useless. If you've got one record in one table associated with one record in table B, why are they in separate tables, right? You could collapse those down pretty easily. Now, there are cases where that does make sense, and we might encounter some later on, but generally that's kind of a why are you doing that? If there's a very good reason for doing that, efficiency or some reason, then go ahead, but there are probably better ways of achieving what you're trying to achieve. Okay. What we're going to start out with is a pre-existing database because we're going to hold off on database design and creating tables until later, and we're going to give a CRUD demonstration. CRUD is the 4 basic operations on any data, right? You can create data, retrieve data, update, and destroy data. Think about this in terms of a list in Java, right? You can put stuff in, you can take stuff out. You can take stuff out, change it, and then put it back in. That's updating it. You can remove things from a list. So you can destroy things in a list. It's not unique to databases. CRUD is 4 basic operations for any data. Okay? With respect to SQL, though, the keywords that we're going to be using are insert, select, update, and delete. So unfortunately, the only one that actually matches is the U, the update, and we've got different keywords for all of these others. But ISUD is not a catchy acronym, right? So I don't know, maybe you could SUDI or DUSI or something like that. You could rearrange it and make it say something, but we're not doing that, okay? Other people didn't do that already. We're going to look at create, update, and destroy first because those are the three the easy ones. So C, again, is creating data. Right? You use the insert keyword on an existing table to insert new data into an existing table. How do we go about doing this? Well, I am eventually going to put this all into code so that you have it for the notes. But I'm going to do all my demonstrations over here in MySQL Workbench. Remember that you can create a connection by naming the connection. Going to the host is cse.unl.edu. You are not the root, you are you. So I am me, C. Burke, right? And you can connect. I'm just going to go ahead and connect immediately because I already have, that was from this morning, I already have that connection set up. Okay, so we're connected now. So I'm going to go ahead and start by using my database. If I just start making queries, right, like show tables, right, there's no database selected. So I'm going to go ahead and use my database, which is named after me. You'll use your database or your partners if you're sharing a password. All right. Now we can show tables. And the results are displayed here in this kind of Excel-looking table here that you can, click on the header and rearrange stuff. You can interact with the data a little bit, but we've got a publisher, platform, game, and availability. And unfortunately, I can't zoom in like I can up here on the actual code. When you're done looking at a result, you can always close the tab right down there. The tab appears in the bottom. So I've got my tables, and I've got these relationships between them, okay? So let's go ahead and create some data. Let's go ahead and create some publishers, right? Now, for the publishers, what data do I need? So let's walk through these pieces of data first of all. The publisher ID is an int. What do you think that's short for? An integer, right? And this little icon right here, what do you think that looks like? It looks like a key to me. Yep, it's a pixelated key, but it is indeed a key, right? That's a primary key. That's its identifier. What is that column named after? Publisher ID. Well, what table is it? The publisher table. What is the primary key of the game table? Game plus ID. Platform plus ID. Availability plus ID, right? Following these kind of naming conventions will mean that there's very little guesswork, right? We'll talk about naming conventions later on. We have a name of the publisher, varchar. That's short for variable character array. And the 255 here says what is the maximum value you can hold. So you can have a publisher with, Atari, 5 letters, right? You can have a publisher with 255 letters in it, including spaces. But if you have a publisher with 256 characters in it, that last character is gone, right? It's truncated. Right? You can put stuff in there, but it'll cut off whatever it doesn't fit. 255 is of historic relevance, right? 255, what's special about that? It's less than 256, which is 2 to the 8th, and 8 is 1 byte, right? So there's meaning to that historically. Now, of course, it doesn't matter with modern database systems, but the habits die hard, right? So 255 is still there to this day, 50 years later after Edgar Cod, right? No, he created it, okay? So let's go ahead and insert into publisher. Now, which one of these I could do both, right? I could go ahead and insert a publisher ID and a name. Insert into publisher, a publisher ID, and a name. Give me a publisher. Nintendo? I think it's already in there. Give me a modern new publisher. Rockstar? The Rockstar's in there. Say what? Okay, Bethesda. Right. You'll find that the data in there doesn't go past 2011, so you know what the last time I played a game was. So if you choose anything after 2011, we'll probably be safe. Okay. All right. So there's the syntax, right? And let me go ahead and zoom out here just a little bit so it all fits. What's at the end? A semicolon, right? Just like a lot of other programming languages. 1970 SQL, 72 I think SQL was created. Right after, or maybe 71, I'm not sure, a semicolon. So it predates the C-style syntax. I believe it was also used in Fortran, maybe. I'm not sure. But semicolons, right? Familiar. What about the publisher ID? Is it safe to use, I don't know, 1? Let's find out. All right. That failed. Do you see the little red mark down there? Right? And if you can read it by squinting, duplicate entry 1 for primary key. So let's go ahead and find out what's in the publisher table to begin with. This is a bit of a preview of retrieve, but let's take a look at all the publishers. 1 through 14, LucasArts through Naughty Dog. I think we inserted this in the morning. I forget who Crash Bandicoot, that was it, right? That's what they put in. There's Atari is in there. There's Rockstar Games. There's Nintendo, so yeah, those already existed, right? But this won't work for Bethesda doesn't exist, so we can put it in there. But can we use the primary key of 1? Nope. Why? It's being taken by LucasArts, which no longer exists, unfortunately. Outstanding game company. So 101. Let me go ahead and try it now. And I get a green check mark indicating success. 1 row affected. That means that I inserted 1 row there. If I select everything out from the publisher again, I see 101 and Bethesda. What about 15 through 100, though? Yeah, there's nothing in there, right? What if I inserted something without a publisher ID? So insert into publisher. Give me somebody else that's not in there already. Okay, fine. Foo Games. All right. That also works. Right? 1 row affected. I didn't have to provide a primary key because the way that I designed this database is I trusted it to do key management for me. Key management is actually a very difficult problem that is solved by RDBMS, right? Finding out, is this key already taken? If so, okay, now I can go ahead and take that. And by the way, I need to block all other threads from grabbing that key ID so that we don't have a race condition here where you're using the key 101 and I'm using the key 101, right? That's all solved by the database if you just let it do its job, okay? And I let it do its job in this case, and we see that it's now 102. Right? Yeah, it goes to the next available one. Now that's an internal thing, right? There are several key generation strategies, and if you're a DBA, you can go in and change those strategies, modify stuff. You can reset that to be 5, right? And then it'll say 5 is already taken, 6, 7, 8, 9, that's already taken, and then start next at 15. When it hits 101 again, it'll say taken, next, 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 next. It'll be quite inefficient if you're doing that over and over and over again. So a lot of the times, databases will be rebuilt so that all the keys are contiguous so that you don't have these big holes in all the data, right? But we've set us on a path here of 102, et cetera, et cetera, et cetera, right? Did I reinstall it? Okay. I didn't think that I oh, no, I didn't. We did that with the games this morning, that's why. Okay. So key management, very, very difficult problem to solve. Let it do it for you. You can insert multiple records. Right? Ooh, what did I just write there? A comment. Comments begin with hyphen, hyphen. Right? Sometimes you can use hash. This is a comment too. Right? Sometimes you can use C-style comments. This as well. Right? I don't think you can do this, not this. Right? Single line comments are not supported. Right? That all depends on your editor and your database. You can't go wrong with that though. Right? The hyphen hyphen. I think that's pretty much universal. I could be wrong on that though. So let's insert multiple records with 1 query. If you want to insert 3 publishers at the same time, or let's do it platforms. insert into platform, since I know that there's nothing in there that will change. Insert into platform name, again, the data ends as of 2011. Values, I certainly know that there were no VR stuff back then, so there was no Vive, right? There was no index. Right? And let's do a third one. I don't know. Okay, what kind of Oculus? Oculus Rift. One C, right? Rift. All right, there we go. Don't buy Oculus. There we go. There, all three have been inserted at the same time. Let's verify that. Select everything from platform. Right. There they are. Vive, Index, and Oculus Rift are all in there now. Right. All with one query. Right. How? Comma, comma, comma. The tuples are all in parentheses here. In fact, again, these are tuples. Right. This is a singleton right here. This is a doubleton, tripleton, whatever you want to call them. They're just tuples in general. Ordered collections of things. This is an ordered collection of two things. This is an ordered collection of one thing. Right? So you can insert multiple records with one query. And I will go ahead and put this over in the notes so that you have it. Right? And note anything that we did. Right? So you can, but should generally not, hard code primary key values. Right? Key management is difficult. Right? Let the database do its job. You can, and in fact should, hard code key values for initialization or test data, right? Because you want predictability there, right? In fact, when I built this database, I ensured that I want to know what keys are going to actually be generated by this, because if I create a brand new table, it could be that the database has been configured to start at key 1 million instead, right? I wanted everything to be predictable, so I went ahead and hard-coded all those values when I created this database initially. Right? And when you create your own test data, sure, go ahead and do that. Okay. Let's see. All right, let's go back over here and let's do a little bit more. All right, let's go ahead and select everything from game. I don't see Minecraft here. So let's insert Minecraft into as a game. Insert into game. What do I need for a game though? Do I need the game ID? I can let that be auto-generated. I need the name, right? The title, Minecraft. But what else do I need? Publisher ID. Okay. Yeah, so insert into game, name and publisher ID. Right? Values, Minecraft, and then, publisher ID. So let's select everything from publisher and see if Mojang, I think it is, right? Do you see Mojang in there? Nope. Unless they existed before 2011, right? So, did they? How old is Minecraft?
Minecraft's 10 years.
Oh, it's 2022 though, so 1 year off. I don't know. Maybe it was in beta then or something. Who knows? Yeah. Right? So what do I need? I need the publisher first. Now, if the publisher were, say, Atari, right, then I have 9 right here in order to take care of this. But without that, without Mojang being in there, what do I need to do first? Insert into publisher, name, values, is that how you spell it?
Yeah.
All right. Thank you. So now it's in there, and I can select it out and find out that, oh, it's 103, right? So in order to do a second record here, I would have to hard code that foreign key value, right? Remember that it was auto-generated over here in the publisher table. That's a foreign key referenced back up to its parent table, and it needs to match. So I could go ahead and hard code it, but does that sound like a good strategy going forward? No. Now, if it's test data, initialization data, yes, you know what the key value is because you set it, you hard coded it. Here's a way that you can do it using a nested query. So let's go ahead and select, and again, this is a preview of select statements, the publisher ID from publisher where name is equal to Mojang. There we go. Surround this with parentheses here. Get rid of that. Oops. I'm going to put that back up here because I'm going to continue to use it. So, walk me through that. Insert into game, name, publisher ID, a hard-coded value here, but then we have what's called a nested query right here. It's going to go to that table, get the publisher ID from the publisher table for the record where the name is equal to Mojang. And I can insert it, and it's there. There is Minecraft with publisher ID 103 now. Okay? That's using a nested query. So you can also use nested queries. So yeah, go ahead.
Can you insert and select with one query? Like nested within your insert?
If you are on Postgres, there's this really cool thing called insert if select or insert Postgres. What is it called? Insert into select. There we go, or something like that, where basically you can query it. If it doesn't exist, it'll create it for you and then give it back to you. So select from publisher, select or insert from publisher where name is equal to Mojang. It's not there. I'll go ahead and create it for you. Here you go. Right? That's a feature that is not part of the core SQL. If you go from one SQL database to another SQL vendor, you may or may not get vendor-specific features. I'm only going to show you the universal features, right? And we don't have access to a Postgres database anyway on CSE server, or maybe we do. I don't know. But at its core, you get access to the MariaDB instance, which is a MySQL clone. Right? What about updating? Right? You can alter an existing record in a table using the update keyword.
What was the asterisk in the syntax?
This right here, that is a wildcard that's selecting all of the columns. Right? So if you, we'll get to it when we get to selection, but if you want only the name, if you want the name and the publisher ID, right? But if you want everything, and I want everything here because I'm just, demoing it, right? Then it gives that to me. Right? By the way, to execute one query, the query that your current cursor is on, Mac, it's going to be Command Enter. Right? If you want to select multiple queries, then it's going to be Shift Command Enter. And I believe if you change out Command to Control, that's in Windows. Otherwise, these two buttons up here, the lightning strike and the lightning strike with an I, do the same thing. Right? And when you do multiple queries at the same time, multiple tabs will appear here. You can pin them, or you can just go ahead and delete them, get rid of them. You can always rerun it. And when you've got something like this, you can always alter something like Pong, go to Pong2, right? You can treat it like kind of like an Excel file. That doesn't change the database. What you have to do is you have to go over here to apply, right? And it shows you the auto-generated SQL that it'll actually execute. Right? So this is an update statement, right? Update game, set name equal to Pong2 where the game ID is this, right? I'm not going to apply. I'll go. Why can't I go back? I don't want to. I want to actually do it. Right? There we go. So I want to show. Don't apply. Right. There we go. But you can do it like that without having to write SQL code if you want. I'm going to show you the SQL code though. Update, and then the table that you wanted to update. In this case, game. Set name equal to Pong2. I don't know if there was a sequel to Pong or not, but let's go ahead and say that I meant Pong2. Oops, didn't work for good reason. Why?
It doesn't know what game you're.
Yeah, which game are you talking about? Right? Now, it stopped me from doing this. If you read this really closely, it says you are using safe update mode and you tried to update a table without a where clause. If I were not in safe mode, and I can shut safe mode off, right? But if I were not in safe mode, what would this query end up doing?
Would it change everything to Pong 2?
Every game's title is now Pong 2, right? I want to scope that down to where name equals Pong, right? This is not going to work either because it's super strict safe mode. Updates and destroys and stuff like that must be done with respect to a unique key or a foreign key. So what was Pong? There, cut, paste, copy, paste, right? Where game ID, oh, how did I remember that the primary key was a game ID?
The name of the table.
Yeah, there's the name of the table, append ID to it, follow that pattern, you never have any guesswork at all, right? Execute that. 1 row's affected, 1 matched, 1 changed, 0 warnings. Let's look at the game table again, and we see that Pong 2 has been changed, or Pong has been changed to Pong 2, right? Okay. Again, without a where clause, it's going to end up doing everything, so be careful. You can shut off safe mode. I'm not even going to show you how to do it, though. Stay in safe mode, right?
So it automatically puts you in safe mode.
Yeah, I mean, that's the default for MySQL Workbench. It is not the default if you go to the command line. So you can SSH into csc.unl.edu. You can start a MySQL client here. The user, here's my, prompt me for my password, please, so I don't show it to you. There, now I'm in, use cberg, right? Update game, set name equal to foo. Should we roll the dice?
No.
No? Okay. I don't know if it's in safe mode or not. I'm sure that there's a way to determine if you're in safe mode. Let's see. List safe mode setting MySQL. Delete under safe mode. Okay. Well, there's how you set it and unset it. I guess I am going to show you there, right? Set SQL safe mode updates false and then true. I don't know how to. I know. I could probably select it. All right. So select. Oops. Okay. Show databases. Yeah, I can say select that from. No, I have to use that. Yeah, so use information schema. All right, show tables. Select that again. Nope, I don't know where it would be. I don't want to waste any more time on that. But again, this will work because you are not you are being more specific. You're scoping your changes down to only one record. You could do something like this, though, where game ID is greater than 10. Roll the dice on that. I don't know. Here, let's select the games and make sure that we're only, screwing up a couple of these. So greater than 20. 6 records matched. Right. And now we've got all those copies of Pong there, right? Yep, safe mode is not entirely safe. So I'll roll that back and show you that you can do that.
So there's like version histories on you.
Nope.
No.
If you want version histories on a database, you're going to have to dump the database snapshot at some point, or do transactions. So what you can do is you can start transaction. I don't know if this is SQL syntax or not. Do a query, query, and then you can commit transaction, something like this, or you can undo everything that you've just done by saying roll back transaction. But that is only the queries from when you started this transaction. So, but every time I execute this is a transaction because I'm only executing one statement. There's no undo. Right? That's why if you're going to run test data, what you do is you put all your test data and your database creation and stuff like that into a file, save it, and then if you ever need to wipe it out and come back to the original, then you need to do that. Otherwise, you need to do what's called a mysqldump, right? And it dumps a database to an SQL file that you can then restore a snapshot. You usually set it up for a cron tab to do this nightly or hourly or something like that. More sophisticated, more expensive databases can periodically do snapshots on your own, but cheap mysql dump is the way to go.
Well, would that be like feasible for big data if it's big enough that it's like?
It depends on how much disk space you're willing to spend, right? Yeah, I mean, you could have a snapshot every event or something like that. In fact, I've seen databases set up so that they set up what are called triggers, so that anytime this table, this column in this table is altered, we'll write another record saying what it was before and what it is now, along with a timestamp, right? And you're keeping a version history in perpetuity if you want. And if your data is changing every second, though, that's going to blow up, right? But if it's small data and you need an auditable trail, right, like bank transactions or something, then yeah, probably want every single possible thing that could go that could be changed. Here, let's go back to the notes here. Safe mode will prevent most, I'll emphasize that, most queries that end up changing multiple records. Generally, you use a where clause to limit the scope of your changes. Right? So again, there was the update. Okay. What have we seen so far? We've seen comments. We've seen also naming conventions. Right? I'll just highlight these as we go along. What are the naming conventions here? First of all, tables, all lowercase. Right? If there were multiple words, I would probably go with lower camel.
Or lower underscore.
I don't know why I did it like that, but I would advocate an upper camel casing actually, because you can very easily see that you're going to have a one-to-one correspondence between your Java classes and a table, right? And what I'm advocating with naming conventions here is that you use the same naming conventions. All of the fields are underscore camel casing, right? Capital I, right? Publisher ID, publish year, right? Capital Y. That's to mirror your Java classes. Old school SQL advocates would say that you would need underscore under or underscore casing. So game underscore ID all lowercase, right? And again, that's old school way of doing it. And if you do that, it's kind of a GNU style where you're killing your pinky every single time to type shift and then all the way across the keyboard the underscore. And I don't like doing that. Right? As long as it's a consistent naming convention, go ahead and do what you want. Right? Are any of those tables pluralized though? It's not the games table. It's not the publishers table, right? It's the game table. It contains game records, and game records are in it, right? All right. Anything else? Bring your attention immediately? Nope. Other than foreign keys are named after the primary keys that they reference, right? So everything matches. Right?
Some of the auto-generated SQL had all uppercase
Good.
keywords.
Good question. So let's go ahead and make a change. Oh, here, let's make a change, blah, blah, blah. All right, and let's go ahead and I'm not going to apply it, but let's see what it would look like again. Update is all uppercase. That is an old school way of doing it because in 1970, did you have color monitors? Nope. Consequently, you didn't have syntax highlighting. And so to offset keywords in SQL, they did all uppercase. We don't live in that world anymore. The modern convention is to use all lowercase, and then use syntax highlighting to tell you which are the keywords. These backticks are there as a matter of course. That's how you escape things out. For example, if you wanted to make a table named update, not a good idea, but that's a keyword. You can't do that unless you surround it with backticks. Right? And that's what this is doing.
Is that like the top left?
Yeah, top left. It's right under the tilde. Right. That's a backtick. Right. And so it's escaping everything out here with a backtick, and then it's putting parentheses where it doesn't necessarily need them. Right. Okay. I'm not going to apply that though. I don't want to screw up that game. Don't apply. All right. That's updates. The last one that is in safe mode would of course be to destroy existing records. Right. To remove, and remember, no undo. Generally, right. Records, use the delete keyword or query. Right. You should use a where clause. Why? What if you don't? Yeah, it'll delete everything in your database, in that table, right? So for example, if I go delete from publisher, there we go. It's not going to let me do that because I'm in safe mode update, right? That would not delete the table, right? You can delete tables if you really want to by dropping tables publisher. We're not going to do that because I still want this database. But you deleting from the publisher, that would just delete all the records in the table. The table's still there. It would be an empty table. So let's go ahead and be a little bit more judicious about this. Where publisher ID is equal to, I don't know, 1. I don't know who they are, but I'm going to delete them. Also prevents me from doing that. Let's find out who the publisher is. LucasArts. Are there any games there by LucasArts? Yep, Lego Star Wars, TIE Fighter, and X-Wing versus TIE Fighter. Awesome, awesome games. Right? Right. So, let's go back to our ER diagram here. We have a hierarchical relationship. We have a parent and a child. The publisher is the parent. We have games, which are the children. The children have foreign key references back to who their parent is. If I delete the parent, right, what happens to those 3 children right there? They're now orphans. Right? We don't want that. Right? We want data integrity. So if you're going to delete a publisher, what do you need to do first? Delete the games associated with that publisher. So let's try that. Excellent, excellent games, but I wouldn't even know. Probably have to do them with an emulator at this point, like a Windows 95 emulator or something. So delete from game where publisher ID is equal to 1. It will not let you do that. Why? That is a foreign key. It's being really, really strict here, right? So let's go ahead and select all the games from publisher and see what I have to delete first. If I sort them, I see that I have to delete game 16, 17, and 18. Right? I could do that. Delete from game where game ID, what was it again? 16, run it. 17, run it. 18, run it. All right? Or I could do that all in one go using an in clause. Right? 16, 17, 18. Or I could have set it up so that where game ID is greater than or equal to 16 and game ID is less than or equal to 18. Right? So numerical comparison operators, that's straightforward. You know all about those. But how do I get the conjunction? It's not ampersand, ampersand. It is and. All right, it's not going to let me do that. Okay, fine. Oh, wait. Because I'm not. Oh, no, read. I should read more carefully here. What else is there? Availability. Let's go back to the ER diagram here. I wanted to delete, I wanted to delete a publisher, but it had children records. So I tried to delete them first. But what about those children? They have children. Grandparent, parent, child. Right? That means that those 3 games were available on some platform, probably PC. Right? All right, fine. Let's go ahead and select everything from game. Let's delete a different publisher. I don't know. Eidos, maybe? Or let's see, 8. That might be available. 10. Where game ID is equal to 10. Didn't work because it's available. Fine. Give me something that's not available. All right, fine. I'll do this in sequence. Let's go back to Eidos. There were 10. It was Tomb Raider, right? Tomb Raider, publisher ID 10. So what could I do with respect to the availability table? Delete from availability where game ID is equal to 10. That makes it unavailable on any system. Right? And that'll work. One row affected. Now I can delete from game where game is equal to 10. And I can delete that publisher that had it. What was it, Eidos? Eidos 10. Right? Where publisher ID is equal to 10. It is just coincidence that those are all 10s. Right? Oh, it was not Eidos? Okay. Select everything from game. Oh, they're 10 and 10. Okay, there's Tomb Raider, publisher ID 10. 12 apparently is what I had to delete. And then Mega Man 4. That shouldn't be. That's not Eidos. All right. I'm confusing myself now. Let's update that. Usually when I do an update, I also show you that you can update the key, the foreign key. So let me show you what I mean. Where is Mega Man 4? Right? Published by Eidos. Is that correct? Eidos. Mega Man series was published by, if you don't know, Capcom. Okay. So let's update game. Set publisher ID equal to 8, where game ID was equal to, and what was Mega Man 4? Mega Man 4 is 9, right? Is equal to 9. There we go. And now it's gone. And now I can delete Tomb Raider, which is 12. Game ID is 12. Delete that. Oh, come on. What? Oh, because I didn't delete its availability. There. Now I got rid of that. Now I get rid of that. And now I can delete Eidos. There. Finally. Right? So if I had to delete from the bottom up, where would I have had to create things? Top down. Create the publisher, then create the game, and then you can make it available on some system. Okay? And let's make sure that it's actually gone. Is Eidos gone? Goes C, D, F. Yep. Eidos is now gone. Okay. Couple of examples there that I'll put in there. Otherwise, those are the straightforward ones. Any questions so far? No? All right, then let's go with the R, which is retrieve records. Right. To retrieve records, you select them. Select from a table. Right. So, for example, retrieve every column of every game record. There we go. Select star from game. Right. The star operator is a wildcard. Right. It matches every column. Right. You can select a subset of columns by specifying them. So let's go back over here. This is a wildcard. It's going to give me all 3 columns of the game table. It's going to give me both columns of the publisher table. If you only care about the name of a game, then you can just go ahead and be judicious about it and select the name. If you want to select multiple columns, you can say name and comma publisher ID from game. Right? And I only get those 2 columns. If you want to switch the order, you can do that. Right? Generally, order does not matter. Of columns, generally order does not matter of records unless you impose an order. In fact, you can do it here too, I believe. Can you do this? Nope, you can't move these around. Oh well. It's just a result anyway. It's a result set.
Can you do it numerically, like column and column?
In JDBC code, we will, because, no, those are for parameterizations. No, you usually just reference the name because there is no first, second, or third. The entire relational model, most of you are in, say, 235 right now, right? Have you gotten to relations yet?
Like onto one-to-one.
Those are the functions are a special case of relations. But if you talked about relations, which are a subset equal of a Cartesian product, there we go, something like that. A relation is you're relating a set onto itself, or one set to another set. Right? You're taking tuples. You can take a Cartesian product of three things. Right? You've probably done subsets at least in Cartesian sets, right? Right? No, a cross product maybe is what they call it instead, right? Well, what is the real number? What are the real numbers built of? Math. Blackboard bold R. Right. Those are the real numbers, right? Well, what if I cross the real numbers with itself? What do I get then? Just one of them is the number line, right? But if you got two of them, what do you have? 2D, and we call that the Cartesian plane, right? Cartesian coordinates, right? And that's where we get that terminology, right? It's you have an x and a y value in the Cartesian plane. If you go with 3, then you've got 3 space, 4 space, 5 space, right? You're talking about dimensional space.
And that's what I think it look like.
If you want to the n, there's n-dimensional space for you, right? That's the base. Relations are the basis of the relational database model system. They are a relation between two tables. Right? All the elements, this is a set over here, this is a set over here. When you combine or join two tables together, you have a relationship between them. When you join 3 tables together, you have a relation on 3 tables, right? And that's what all these queries are actually doing. They're operating on sets and set operations. Right? Like that in clause that I showed you, right? You've seen that before with sets, hopefully. X in A. Right?
Yeah.
What do we read this as?
X.
In, right? In fact, that's the LaTeX command for it, is in, right? And that's where the in clause comes from. So anyway, this is a wildcard. You can, of course, select a subset by specifying them. Not only that, but you can also use what's called an alias. So if I were to redesign this, I probably would not call the name of a game name. What's a more appropriate term for the name of a game?
Title.
Title. As title. What happened to that column right there? It's now called title. It did not rename the tables column. The tables column is still named name, right? All it's doing is changing it for the purposes of this result right here, right? If I select everything from game again, I see everything is still exactly the same. Right? But you can switch things around. You can alias them using the as. In fact, it's such a common operation, you can elide the as and it'll still work. But don't do that. Later on when we do joins, do that. Because writing as all the time is not going to be fun. Right? So you can specify by specifying just the subset of columns that you want. Right? Generally later on, we will discourage the use of the star operator in your actual Java code. And the reason for that being is if you are transmitting this data over the wire, right, that's your bottleneck. You're wasting bandwidth if you're not going to actually do anything with that data. Right? If you use the wildcard, that means give me everything. Right? Even if at the other endpoint I end up ignoring the publisher ID. I just want to print out the name of the games. Right? Only send me the name of the games then. Right? Don't send me all that extraneous data, wasting bandwidth. And so you want to be more judicious about it. When you're in here, who cares, right? You're just typing SQL stuff, Yeah.
So there's going to be like a Java interface.
Yep, JDBC, Java Database Connectivity API. Yep. All right. You can use basic logic operators with your where clause. We've seen some of them already. You can use numerical comparisons, right? Less than, greater than, less than or equal to, greater than or equal to, equals, right? Not equals equals, but equals. And then the not equals is not equals. Right? You can do strict string comparisons. Right? So for example, select everything from game where name is equal to GTA. Right? And I get back that one game there. A single equal sign, so it's kind of like the assignment operator, but actually there are variables in SQL, but it's actually not common to use them because SQL is what's called a declarative programming language, which is a functional programming language. Functional programming languages eschew variables entirely. They don't want you to have state, intermediate state at least. Right? All right, well, what if I go GTA all lowercase? What do you think? Nothing. That tells you case sensitive. That's because that's how I set it up. That all depends on the database and the table and also the collation standard. Thankfully, everything by default is case sensitive here. You can, but it's not a very good idea, but you can go and make a database that is not case sensitive. All right. You can have fuzzy string comparisons using the like clause. So I want all games from game that start with a capital G, where name is not equal to, but it is like G, and then there's another wild card. % will match anything, 0 or more characters, any character whatsoever. So I see that I have GTA through GTA 4. Right? Anything that begins with a G. Anything that ends with a G. Anything that begins with a G. Right? Or let's go with a lowercase g. Right? Am I going to get that? No, because it's case sensitive. What about ending with an uppercase G? Nothing is there. Right? Ending with S. I think we're going to get at least Super Mario Brothers. Right? Yep. And Lego Star Wars. They both end with a lowercase s. Right?
What's the name of the string operations where you can search stuff? I forget.
Regular expression. Yeah, no, you can't go for a full regular expression here. But you can do combinations. For example, anything that has an S in it anywhere. So match anything, a lowercase s, and then anything else, including those Star Wars and Super Mario Brothers, because anything includes nothing. So I'm going to get a lot more here. Anything with a lowercase s anywhere in it, basically. Anything with a single space in the title. Anything with 2 spaces in the title. Nothing, because if it's 2 words, I just did 1 space. Right? You can also match single characters. So for example, any single character, then an A, and then anything. Right? So what this is any character, it begins with any single character, followed by a lowercase a, followed by anything else. And I get Katamari Damacy out of that because it's a capital K, lowercase a, and then anything after that. Right? What about a lowercase a in the 3rd position? So any 2 characters followed by a, none. And I'll get Katamari back here because it's K-A-T-A, right? If I've got 3. And then I'll get Mega Man 3 and Mega Man 4 too, because M-E-G-A, M-E-G-A. Right? So single characters on the underscore there. Okay. Those are 2 other wildcards, right? And that's all fuzzy string comparisons, right? Partial string comparisons. I'll put that into code mode here and there. Okay. And note that the %, oops, %, come on, %, matches any characters, right? 0 or more, right? The underscore matches any single character, any, right? You asked about regular expressions. May not be interoperable. I'm sure that there's probably a way that you could do it. Yeah, well, not packages, but MySQL regular expression matching. I don't know. Regular expressions in MySQL. Okay, apparently you can do it. Show me an example, though. There. Where name regexp. Let's try it out and see if it works. Select everything from game where regexp, and then a regular expression in, so, I don't know, m followed by any number of characters.
Does it have to be?
Say again?
Does it have to be single quotes for you?
It should not have to be. Well, let's find out. Maybe it does. It's not even liking regx. No. So MariaDB, it's not letting me do this at all. It doesn't like that. So why are you telling me that I can do this in MySQL? I call bull. It's probably a versioning thing, maybe. Or maybe it has to be enabled or something like that. Yeah, whatever, right? So, yes, there are ways to do it, but it's going to be vendor specific. And now your SQL is not, you can't take your Postgres SQL and move it over to MariaDB, probably. Right? It's going to be done differently. Right? Okay, so can use string comparisons, et cetera, et cetera. All right, where's my distinct? There we go. Nope. Okay, fine. So select everything from game. So you see that we've got repetition here of publisher IDs, but we don't have repetition of their names. Right? It is a reference back to a record where all the data associated with that record is only stored once. References can be stored multiple times here, though. If you only want distinct ones, say publisher ID, right? I'm going to get all the publisher IDs in the game table. If you only want distinct ones, you can slap on a distinct keyword in front of it, and now all the duplicates are eliminated. Right? You can use that in conjunction with what's called an aggregate functions. Right? I want to count, select count of everything from game. That will give me the number of game records in there. Right? There are 24 game records. It's only one result. What is the name of that column? Right? Count star, right? Why? Because that's what it was up here, right? If you want something a little bit more readable, you can use, again, an alias as number of games. Right? There we go. I can use that in conjunction with this distinct clause up here, or this distinct keyword, to say, how many distinct publishers do I have in that game table? So select count, distinct publisher ID from game as num publishers. 10. I wonder how many publishers I have in the publisher table. Should it be 10? Not necessarily. Select count of as num publishers from publisher. I think it's going to be 13 or 16. I've got 16 publishers here, right? But I only have 10 publishers that have actually published a game, right? So how many records, or how many publishers are there that don't have any games? 6? Okay. What if I wanted to do that with all one query? That gives me the number with games. That gives me this. Oh, I'm going to have to join. I'm not going to be able to show that right away. Oh, yeah, I can show this to you. So I can show it this way at least. So we said that there were 16 publishers. 16 minus however many has published the game, and that gives me 6. Right? What did I just do there? Basic math. What about division? It's weird, 1.6, but that is a nonsense number, but you can do it. Addition, 16 plus 10 is going to be 26. Multiplication. Worked. Why? Because I didn't put it first. Right? Select star would be interpreted as the wild card. Something and then the star is going to be interpreted as the multiplication. Right? So you can do basic math here if you want to. I'll do minus though. There we go. All right.
Is it gonna freak out if you try and say -16?
Probably not. Negative 26. Negative 16 minus 6 minus 10 ends up being negative 10 or negative 20. Okay, we're right. Yep. Right, there we go. All right. You can do other aggregates. For example, select the minimum among publish year from availability. What's that going to give me? 1985. That's the oldest game. Right? There's the publish year right there. How would I get the newest game? Max. 2011, like I said. I haven't played a game in 11 years apparently now. I've played games since then. I just haven't cared enough about them to put them into this database. Splatoon 2 and Splatoon 1. Right, there we go. All right. AVG. What does that tell me? That's the average of all the publishers. Not that that's a useful statistic, but you can get the average. Right? There are a couple of dozen other basic math functions and basic aggregate functions that you can use here as well.
Like median?
Medium? What would that, med? Nope. Medium? Median? Nope. Mean? Mean is not going to work because we've got average. I don't know. RTM. All right. There we go. I'll put this in over here for you for aggregate functions. Aggregate functions. SQL. There we go. Then there's another type of aggregate function that I'm going to bring up a slide to show you really quick here. Where is it? Darn it. I should have brought this up already. There we go. All right. So here's a toy database where I've just got 3 columns. I've got the title of a book, I've got the author, and then I've got the number of copies of that title that I have. So for example, Naked and the Dead, I have 10 copies of that. Hitchhiker's Guide to the Galaxy, I've got 2 copies of that. That was written by Douglas Adams. There are 3 books here written by Douglas Adams, 2 by Norman Mailer, and only 1 by Orson Scott Card. Now what I want to know is how many total number of copies of Douglas Adams books do I have? 4 plus 2 plus 1, I should get 7, right? Likewise for Norman Mailer, I'll say that I've got 10 plus 3, 13 copies. I'm going to group them first by all the authors. Once I've grouped them by the authors, I can do what's called a data projection. So what do you mean by projection? Take a sphere. If you project a sphere onto the wall, what kind of shape do you get? A circle. This was a 3D object. The thing on the wall is now a 2D object. That's a data projection, right? You're projecting it down. What are you doing in terms of dimensions? You're making it flat. You're flattening it, right? You're taking away one of those dimensions. Right? We're doing the same thing here. I will group these by the author and then take away the title dimension, flattening all of the number of copies. Right? So 4, 2, 1, 7. 7 plus nothing is just 7. And then 10 plus 3 ends up being 13. Okay? That is achieved by this group by clause. So let's go ahead and try it over here, first of all. Let's go ahead and try to get how many games for each publisher. So again, I'm going to go ahead and keep my attention here on the game table. So let's first of all select everything from game. Now, I can kind of do this by grouping it by just clicking the header here, and it'll end up being grouped by publisher ID. Right? So let's go ahead and add that group by publisher ID. Right? And when you do that, you group everything by publisher ID, and now the publisher IDs are all unique. But is that telling me how many games I have by each publisher? No. I need to use this in conjunction with one of those aggregate functions. Right? So I'll take the publisher ID, comma, count of everything from game grouped by the publisher ID. Right? There we go. There are the publisher IDs that we have before, and over here are all the counts. To show you that this is actually correct, again, let's go ahead and just select everything from game. All right, who is publisher ID 1? I don't know, it's LucasArts, and they've got 3 games there. Publisher ID 5 is going to be 1, 2, 3, 4, 4. 6 is going to be 1, 2, 3, 4. 8 is going to be 1, 2, 3. Right? So 3, 4, 4, 3 if we ordered them. Let's do this again. 3, 4, 4, 3. Right? And again, I am grouping it by the publisher ID and then doing a count of all those things. Right? I have taken that 3-dimensional data and projected it down onto just 2 dimensions. Count is kind of unsatisfying, so I could alias it as number games by that publisher. Now, remember we had 6 publishers with no games at all, right? Do you see them here? Nope. What would we have to do to get all of the publishers with no games? There would be a publisher record, but no children. Right? We call them dinks. Have you ever heard that term? I'm not a dink, but all my in-laws are dinks. Double income, no kids. So single income, I guess, because single records. So sinks, right? Single income, no kids though, right? So how do I get those records? I have to start over at the publisher table. And eventually I will do some sort of projection and I should be able to get zeros out of these things. Not only that, but I should be able to get the publisher name instead of this mysterious foreign key. Instead of 1, I should have LucasArts. Right? That's going to require me taking multiple tables and joining them together. Right? For example, join the publisher table onto the game table. I'll just show you the syntax here really quick so that we have something to work with next time, but then we'll get into it deeper then. So select everything from publisher, and because I don't want to write publisher and publisher over and over again, I will make an alias of publisher. I'm aliasing the table itself instead of a column, and because it's so common, I'm just going to go with P without the as. Right? We can elide those things. There's another 50-cent word, elision. Right? You're taking things away. You're eliding them because it's not necessary. Right? Select everything from publisher P. Join the game table G as G. Right? On. Now, how are these 2 tables related together? Should the name of the game match the name of the publisher? No. What is the relationship between these 2? Publisher ID. So if the publisher ID over here matches this publisher ID over here, those are the related tables, right? On p.publisher ID is equal to g.publisher ID. There. I get Rockstar Games has published GTA 1, 2, and 3, and 4. Right? I joined them together. What if I didn't have that on clause? I get how many results here? A lot of results. But am I getting LucasArts produced GTA 4? Is that correct? Nope. What did I just do here? Everyone produced every game. Mathematics. What does that correspond to again? Table A, join, this is called a cross join or a Cartesian join or whatever with table B, right? That's all pairs. Now, if it's set A and a set B, if you've got 5 things over here and 5 things over here, how many possible combinations are there? 5, 5, 5, 5, 5, 25. How many combinations are here? Remember that we had to select count of from publisher. So we've got 16 publishers, and we've got how many games? 24. And if I went down here and asked for a count here, what's your prediction? 16 times 24. Pull out your calculator and verify that that's 384. This is called a full join, and it doesn't make any sense, right? Because you are joining records together regardless of their actual relationship in your table. If you have, if you did something like this, join, select everything, join on their name, g.name is equal to p.name, you're not going to get anything because there's no publisher, Eidos. I mean, here's Eidos, LucasArts. There's no game LucasArts. GTA 4, there's no publisher name GTA 4. Right? And so you're going to get the wrong results here. You have to join how you design the database on the foreign key here. All right? All right, we'll pick it up there next time.